Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at another AP Calc Bc FRQ from 2024. Today we're taking a look at question 2, so let's get straight into it. A particle moving along a curve in the xy plane has a position x of t, y of t, and at time t seconds, where x of t and y of t are measured in centimeters. It is known that x prime of t is equal to x 8t minus t squared, and y prime of t is equal to negative t plus square root of t to the 1.2 plus 20. At time t equals 2 seconds, the particle is at point 3, 6. Find the speed of the particle at time t equals 2 seconds. Alright, so we know that the derivative of position is going to be speed. So we have our horizontal speed and we have our vertical speed. And the way we're going to find our regular speed is by using the Pythagoras theorem in order to find our speed this way. So let's find out our speed in the x direction at 2 seconds. That's just going to be 16 minus 4, that's 12. For this one, I think we're going to need a calculator. We get negative 2 plus square root of square root of 2 to the power of 1.2 plus 20, which gives you 4.7. So negative 2 plus 4.7 gives you roughly 2.7. So there you have it. And now we square 2.7. 7.29, we square 12. 144, we add these together, and then we take the square root of that, which is 151.29. Which gives us 12.3. So there you have it. For A, your answer would be 12.3 centimeters per second. Let's take a look at part B, which is asking us to find the total distance traveled by the particle from 0 to 2. Show the setup for your calculations. All right. So, and the way we're going to do this is we're going to take the integral in both the horizontal and the vertical from 0 to 2 to see how much it has changed, because we know that at 3 seconds it's going to have reached the point, or sorry, rather in 2 seconds it's going to reach this point. So we can find the distance between the point it's at 0 seconds and the point it's at 2 seconds. So let's do that right there. Math 9 in order to get to the integral screen. 0 to 2 of 8x minus x squared dx. We get 13.3. So 13.3 is our answer for how much distance is traveled in the x direction. And now let's do the same thing for the y direction. 0 to 2, negative x plus the square root of x to the 1.2 plus 20 dx. There we go. We get 7.2. So here we have the distance traveled horizontally in the first 2 seconds. Here we have the distance traveled vertically. And once again, we're going to do the Pythagoras theorem to get the total distance traveled. 7.2 squared, 51.84, plus 13.3 squared. This gives you 228.73. And when we take the square root of that, we get 15.1 centimeters. That is how much distance it travels from 0 to 2. Now let's look at part C. Find the y-coordinate of the position of the particle at time 0. That would have been a lot easier to do if I hadn't just deleted how much the position had changed, but we can just do that again. So here we get, we'll do math 9, find the difference in position from 0 to 2 of negative x plus the square root of x to the 1.2 plus 20 dx. That gives us 7.2. So it travels 7.2 in the positive direction and ends up at 0.6. So in order to find what the original position is, it is 6 minus 7.2. So it starts at negative 1.2 centimeters, or 1.2 centimeters below the y-axis. It says for the time interval 2 to 8, the particle remains in the first quadrant, meaning that both the y and the x are positive. Find all the times in the interval 2 to 8 where the particle is moving towards the x-axis. Alright, give a reason for your answer. Okay, so the way we're going to do this is that we're going to, what it wants us to do is to find when it's moving towards the x-axis means that y is going downwards, meaning that y prime is going to be negative. So it's asking us when y prime is negative. So we can just graph our y prime. Y equals, we press y equals on our calculator, negative x plus square root of x to the 1.2 plus 20. There we go, and then we graph that. And so it appears there's, as you can see here, there is a point where it crosses the 0 line. So in order to find out what that point is, you go to the y2 and you put 0 in there, and then you graph again, and then you do second trace, you press intersect, and you find out when these two lines intersect, which is at 5.22 seconds. So from the interval 5.22 to 8, so when t is 5.22, between 5.22 and 8, the particle is going to be going towards the x-axis, and that is because y prime is negative, meaning that the slope is going to be negative. So therefore the particle is going downwards into the x-axis. There you have it, guys. That's how you would solve this entire problem. If you have any comments, questions, or concerns, leave them down in the comment section below. If you enjoyed this video or learned something, make sure to leave a like or subscribe. That would be greatly appreciated, and I'll see you guys next time.